Okay, so here's our second example of about parallelogram things. And this time we're deciding if we can say each picture is a parallelogram based on the markings. So you have to know your properties of parallelograms to know what you're looking for. In this first one right here, I'll call this number 1, we have what looks like a parallelogram, and all we know are some things about the markings on the diagonals. And so this diagonal has 1 tick mark on each side. So that means it's cut in half, right? Because each side is the same, so it got cut in half. And then this other diagonal has 2 tick marks on each side. And again, that would mean this like center point, each sides of it are the same because they have the same number of tick marks. So since both of our diagonals are cut in half, they're bisected, we can say yes, this is a parallelogram, and if you wanted to put a reason or one of the properties, it's because the diagonals bisect each other. So that's our first one. If I call this one number 2, again, we're deciding if it's a parallelogram. And this time we have some things in our angles. So we need to decide if those angle markings let us be able to say that it's a parallelogram. And so one of the properties of parallelograms is that the opposite angles are congruent. Okay, we know that that is true. Yes. Because 85 and 85 are the same. The other property about parallelograms and angles is that the consecutive angles have to add up to 180. So if I take 95, so these angles that are next to each other, U and T, they should add up to 95. They should add up to 180. So 95 plus 85 is 180, so that's a good sign. We don't know W right now. Earlier in the chapter, or in this unit, we figured out that shapes with 4 angles all together have to add up to 360. So if you add the 285s together and add the 95, you get 265. And if you subtract that from 360, you get 95. And so now we can see that both sets of our opposite angles are congruent, and both sets of our consecutive angles all the way around add up to 180. So yes, this is a parallelogram. And its reason would be because the opposite angles are congruent and the consecutive angles add up to 180. I'm not sure what's happening with my computer right now. Opposite angles, congruent, consecutive. And again, when things add up to 180, the fancy word for that is supplementary. I'm going into the next problem, sorry. Okay, our next one. Again, we're deciding if it's a parallelogram. We have markings similar to this first one on our diagonals. However, this time, if you look at this diagonal that sort of goes down when you look at it from left to right, one side of that has 1 tick mark. The other side has 2. So those tick marks mean those segments are different lengths. So that diagonal is not cut in half. And the same is true when you look at the diagonal that goes up. When you look at it, it has a positive slope. This little first section has 1 tick mark. The second section has 2. So that diagonal is also not cut in half because the 2 pieces don't have the same number of tick marks. So this is not a parallelogram. And if you wanted a reason, you would say the diagonals do not bisect each other. And then finally, this fourth one over here, all we have is some angle markings across from each other. We don't know anything else about these angles. We don't know if they're equal. They might look like it, but we don't know. So all we know is that one set of opposite angles is congruent, but not both of them. And to say it's a parallelogram, you have to know both sets of opposite angles are congruent. So this is also not a parallelogram. And again, your reason would be, I'm running out of space, right? It says parallelogram. Your reason would be you don't know that both sets of opposite angles are congruent.